Thank you everybody for joining us in this section. So this section is will be presented by Yang-Ting from Taiwan. He's currently actually in US. So thank you Yang-Ting for being our speaker today to present his topic Taiwan LLM. So in fact, we invite Yang-Ting to present because this topic is about how their team work out the local LLM for Taiwan. And Taiwan is using traditional Chinese, and the Taiwan Chinese is a different culture perhaps different from China, different from Hong Kong. So their experience in building up their LLM, I think, will be a very good reference and very good experience sharing for people in Hong Kong if we want to do Hong Kong, let's say Cantonese LLM. So let's welcome Yang-Ting. We'll pass the stage to you, Yang-Ting.
Thanks everyone. Thanks Scotty for the kind introduction. So hello everyone, I'm Yen-Ting. I'm from National Taiwan University, and I'm currently a Ph.D. candidate in the CS department. So thanks PyCon Hong Kong for having me to talk about our project Taiwan LLM. So today I will talk about how we build, how we train the LLM, and what and how we get the data, and how much is the compute. So let's get started. So Taiwan LLM has started since August 2023, last year. So when I was interning at Amazon last year. Right now I'm interning at US and Meta and in Walmart team. So last year, when I saw the ChatGPT came out, we thought of course I'm a big fan of LLM because I have been doing the NLP research for years, but ChatGPT was great, but until July last year, ChatGPT cannot speak consistently Taiwanese Chinese. So what is different between Taiwanese Chinese and mainland China Chinese? So we share a lot of same vocabulary sets, but some of the shared vocabulary means differently. Like if you know Mandarin, there are many these kind of words. So if the ChatGPT can only say mainland Chinese, it will be very confusing for the ChatGPT user or the LLM user in Taiwan. So this motivates us to build our own language models. So right now I'm sharing the version 3. And this work was done with my PhD advisor, Vivian, Chen, and I. So in case you don't know Taiwan LLM, we top the academic benchmark in terms of unlike the Taiwanese tests, the Taiwanese evals, and we are also on par with proprietary models on crowdsourced leaderboard. And most importantly, NVIDIA Taiwan sponsors us the compute, and our model is featured in their sovereign AI blog post. And if you are interested in using our model or build upon our model, you can use the API provided by hosted on NVIDIA Cloud. So let's start with how Taiwan LLM was trained. So I think all of you guys are familiar with machine learning, AI. So at least you heard about this. So the most important thing in AI training is the data, and we will talk to how we get the pre-training data, how we get the dialogue data to make the language model chattable, and third, how to get the feedback data. So we have a website called twlm.com. You can go to check with our model. The first question is, do we need a localized AI? So I just say my motivation for building Taiwan LLM, and there's a lot of people that are saying that building like sovereign AI is important for a country, a region, or any culture. And for me, the starting point was I asked ChatGPT, where is NTU? So ChatGPT replied me that NTU refers to Nanyang Technology University in Singapore. So this actually really pissed me off. So we want to have our own Taiwan LLM that responds correctly that this is National Taiwan University. Okay, this is a joke, but this is actually one of this is the first test when I was training my model back in 2023. I actually don't have any evaluation set. I'm not sure whether I'm doing it right or wrong, but I just keep asking the model, where is NTU? And I think the model I'm training using just a few GPU, and after 3 or 4 days of training, the model start to learn where is NTU. So this is the first evaluation questions during my development. So yes, we need localized AI, and not only localized AI, we need an AI with general knowledge. We don't want the AI just know things in Hong Kong, things in Taiwan, things in Japan. We want the AI also know the mathematical reasoning and like a use tool, and probably we want an AGI with localized knowledge. So I will talk why generate how we retain the general knowledge in the models later in the pre-training data. So the next question is the most important success factor in AI is skill. I think everyone agrees now. The larger the model it gets, the larger the data they train on, and the model will get. And the skill is defined as compute, and compute can break down to data and model size. So we will not talk about model size here. We were just talking about how to get as much as data. And as the scale grows, the researchers have found out that there are many emergent ability that can show up if you're training more data, training bigger models, and right now we are hoping we can get AGI by just scaling. And where are we now? Where are Taiwan LLM right now? So if on the right hand side, this is GPT-4, and on the y-axis, on the vertical axis, the lower the better. So ChatGPT is rumored to be 10e25 scale, and Taiwan LLM V1 is 4 order of magnitude smaller than ChatGPT 4, and version 2 grow 10 times, and version 3 grow another 10 times. So right now we are just 2 order of magnitude smaller than GPT 4. So of course we cannot direct compete with frontier models like Llama, OpenAI, Anthropic, Google, but this shows that it's possible. It's not impossible to scale to like 1% of the frontier model compute, and this already gives very good results. So what do we need for a scaling localized language model? How do we localize language model? So the first one is, of course, we have to build upon the giant. We have to build upon like US foundational model, or you can use like Qwen from Alibaba, DeepSpeak. That's also fine. But you are using Llama from Meta, and as our foundational model, and train on top of that. So the model already knows something very well. The model knows Western world really well. The model knows math. The model knows the basic things. So we don't have to rebuild the wheel. We don't have to pause something that the model is already learned. Then, of course, you have to get GPU. So I won't talk much about this. If you're a corporate, you can maybe rent something online. And the most important thing is data. The backbone of any good LLM is good data, clean data. And by data, there's actually three types of data. The first one is just like textbook, plain text, or the website and news article, This is the first type, and we use in stage 1 for continuous pre-training, CPT. The second type of data is conversation. It's like the human-human conversation or human-bot conversation or any kind of conversation is second type. And we use that in the SFT, the second stage, supervised fine-tuning. And the second stage is you have to get and pairwise ranking data, or you have to get user data, like we call it feedback learning, feedback data. The user can annotate like the A/B testing, which response is better, and if A response is better than B, something like this, or the user can just sums up or thumbs down. That also works. That is also feedback data that we use in the final stage of fine-tuning. So of course, the first stage, the continuous pre-training requires most of the like 99% of the compute and the data. So here's a breakdown of what the things that we train on. Unfortunately, I cannot tell the exact source of the data because that's against Taiwanese law, against the copyrighted law. But we have web data, social media, news, legal documents, and books, Wikipedia, research data. And the last thing is synthetic data. We use model to generate even more data about them. So we train roughly around 500 billion tokens. So if you're not familiar with LLM token, which means roughly the same to characters in Chinese, one token is about the same as one character, Chinese character. So we train on 500 billion and around 200 billion Mandarin characters, and the rest 300 is English and programming languages. And 200, you might not get like 200 billion. How much is 200 billion data? So it's like tens of thousands of the full series of Harry Potter and multiplied by another 100 or another 1,000. So that's really, really, really a lot of data. Okay, so the first part, how do you deal with web data? Do you have to record it again? You have to download again? No, we just use a project called Common Crawl. Common Crawl has been crawling the whole web since 2008, and there's enormous amount of data there. There's image, text. We only take the text part, and after filtering, only 0.1% is traditional Mandarin. I guess it's somewhere similar ratio to the Hong Kongese corpus, because at some point I filter out traditional Mandarin and Cantonese and Japanese and some of the Southeastern Asia languages. So I guess Cantonese is roughly the same amount of data in web. So web data is really noisy. It's really dirty. It's had a lot of artifacts. So how to filter this kind of web data? Because web data is like is the most important part of our pre-training corpus, and there's a lot of open source filtering corpus filtering tools for you to clean your data, but none of that can really do the tricks. So why? So researchers have found that there should be a Chinese specific filters. So because there's a lot of I'm not sure you can read this, but there's a lot of porn content in Chinese speaking websites. So that's a huge issue. And even ChatGPT cannot solve it. They don't solve it because in GPT-4o's tokenizer, you can see a lot of like bad words in their tokenizer. So you can see that they cannot, they forget to filter it out. So how do we do this? So you're I guess none of them you're familiar with this, but what's important is actually these bad words. We manually inspect the data and put some bad word in the blacklist, and it just filter it out. If a corpus contain like pornographic words, will filter the whole website out. And another important filter is simplified Chinese and traditional Chinese filter, because I don't want any simplified characters in our model, because this will really confuse the model, and it's really hard to correct the model in the post training. So we want in the pre-training, the model never seen any simplified Chinese, even though the model don't see simplified Chinese in our continuous pre-training, it can still say simplified Chinese. So that's, if you are care about simplified Chinese performance, that is an issue. Okay, so another tricks that we use is we use the original English Llama 3 to do the filtering. We prompt the model and ask the model to see is this corpus educational? Is this well formatted? I'm trying to train on it. Can you score the corpus from 1 to 10? And we'll take everything above 6. So let's. This is very technical. If you're not familiar with this, it's fine. So without so we do ablate on with this kind of model filtering and without this kind of model filtering. So with Llama 3 filtering, the training loss gets lower, which is good, because we want to get low loss. And this is not really huge, but in terms of training stability, this is kind of reflect the training stabilities. And the purple one, so with the filtering, this training goes much smoother than without the model filtering. So this is very important for us. Okay, so if you are doing a startup, if you are a small startup, want to train your own language model, maybe you just using the model filtering can solve a lot of issues. You don't have to look in every rows of your data. Okay, that's web data, and another thing is social media. Social media is important because it teaches us the localized slang or some jokes and how we talk, for which is not presented in the web data, because social media is special, right? B-Card is one of the localized social media in Taiwan. We actually don't train on Facebook, because first, Facebook is hard to crawl, and there's so much spam and so much, and the article is too short in Facebook. So we train, Dcard is one of the localized media. And also there's a website called PTT. I guess you guys don't know this. This feel really Y2K, because this is really old. But there's a lot of corpus, there's a lot of good stuff from the 80s, 90s, or the 2000s are in this kind of BBS forum. So we also train on this. Okay, so you should do everything filtered to web data, also to the social media, and you can use also the metadata to do the filtering, like different like the user or the channel or the board, that kind of metadata to do the filtering. Okay, so one of the most important contribution of our model is our model can pass the bar, the first phrase of the bar exam, the lawyer bar exam in Taiwan. So because we train on a lot of legal documents. So we train on, of course, the laws, the every law in Taiwan, and also the court judgment. So the court judgment is actually a really good corpus for the model to learn the reasoning, because in the judgment report it shows what happens and the chain of reasoning that comes to the final verdicts. So this kind of corpus is actually makes our model more logical and have a good sense of the localized thing, because every law case are documented really properly and using a good words, and there's actually really low noise in the court's judgment. And court judgment is open in Taiwan, so you can just one click and download everything. You just have to do a little of cleaning. Okay, that's don't have the time to go through everything, so let's just jump to the syntactic data. So we use a model to paraphrase our corpus again and we'll train the model. So okay, I don't have much time. Let's fast forward to the important part. I get it. Okay, great. So how do we alleviate model from forgetting word knowledge? Like I said, we train on foundational model llama. So llama already have a good reasoning capability. We can do math reasoning, use Tor really well, but we don't want to lose that. So you have to train. We train like 200 billion token on Chinese. So we train another 200. We mix another 200 billion tokens in English into the training. So this is very important. We don't want the model just localize and forget every basic knowledge. So you do the data mixture. So this can alleviate this issue. Okay, so for the pre-training part, we train two model, one larger model, one small model. We train on a cluster set up by NVIDIA Taiwan and Taiwanese government. And just recently, they set out this year. It's around 500 H100, and we train on half of that. And if you train on the AWS, it will get around $1 million US. If you calculate in using the on-demand price, but I guess it's much lower than that if you really want to train on the cloud. Okay, so we have finished pre-training. So pre-training takes a lot of time, but not actually a lot of effort in retraining. You have to do it once. So that is just one-time effort. So after pre-training, the model can just you cannot chat. The model cannot chat like ChatGPT. It can only continue your sentence. This is not what we want. So we want to make the model in a dialogue fashion. So we train on dialogue data. So dialogue data is actually much more easy to collect. So there's a lot of good data in English. Then if you want to train Hong Kongese LLM, you can just use ChatGPT to translate this kind of data. It will not be perfect, but you can. But this is a really easy way to leverage the English data, and you just have to manually written a few thousand or a few hundreds of conversation. If you find a failure, you write 10 example and training. If you find another failure mode, you write another 10 example and into the training. So this is how we do in the supervised fine-tuning stage. So after SFT, your model is good to go. You're good to deploy your model. So we deploy our model not only on twllm.com. We also have another testing blind test A/B testing website called Taiwan LLM Arena. So the URL is arena.twllm.com. So the user can ask the same question to two model anonymously, and the user can select the left side is better or the right side is better. So in that way, we can get the preference of the user. It's not always our model get a vote, but
if we collect the data and continuous fine tuning on it, our model will be more preferable by Taiwanese users. So we use a technique called DPO. This is one of the reinforcement learning algorithm that it can improve the model alignment. Alignments can mean a lot of everything. It can mean a lot of things, but here alignment means Taiwanese preference to me. Okay, so if you haven't tried it, you can just try it. We have two models out there. The first one is 70 billion. The other one is 8 billion. So if you get stuck, the model, maybe my server gets it's very busy. So you wait another second and try again. Okay, so I have been doing this for years, for over a year. So, and there's a tech company, MediaTek, which makes phone chips, and they are also doing this. And Tide, which is funded by our government, and are also doing this. So, not only one player in Taiwanese LLM games. So here comes evaluation. So we collect a lot of high school, middle school, multiple choice questions and test our language model. So the questions looks like this. This is one of the biology questions. So I'm not sure right now I can still teach the language model because I actually don't know most of the questions in the evaluation sets. But our model is better than the original Llama. It's better than GPT-4. It's better than previous Gemini. I'm not sure that it is better than current Gemini, but it's better than previous Gemini. And it's very strong on academic benchmarks. So so this is academic benchmark, but this is not enough. So what we care is Taiwanese alignment, right? So we have another evaluation set called Taiwanese truthful QA. So if you can read Mandarin, you can read it now. So if you cannot, the question is asked, which item from Taiwanese breakfast shop is likely to make someone go to the bathroom easily? So if you are Taiwan, you can answer, you can definitely answer this very, very easily. But if you ask ChatGPT or Quen from Alibaba, you cannot answer it. So this is one of the great questions in the evaluation sets. So the answer is this. So next time you go to Taiwan, you can try this you can try this breakfast shop and try the milk tea. You can try this, but don't take too much. Okay, so we train on a lot of Taiwanese corpus. So of course we top the benchmark and we write the benchmark, and so we know what we know the evaluation. We know how which direction to go for. So of course we are the top in this benchmark. And yeah, so there's also a lawyer qualification results, and 60 is, if you get 60, you can get to the second round and the model gets 60. But I'm definitely know that the model cannot get the rest of the rounds. Okay, so so one thing I think the most important in evaluation is the user feedback. So like I said, we have a A/B testing website. The user can vote anonymously to hit the model. So they can see the model name after they vote. So before they vote, they cannot see. So this removes a lot of brand name bias. So we are on par with the proprietary models. Okay, so that is my talk. So thank you guys for listening. I think we will have a lot of comments when we are building Taiwanese language model, and if your guys are building like Cantonese language model. So feel free to ask questions, or you can just reach me out at the social media. So you can just Google my name or go to TWLM and write me a mail if you have any questions about training localized LLM. Thank you.